Good afternoon. My name is John Vaughn. I'm the CEO of the Quest Oracle community, and I can't believe we're almost through the first day of INSYNC. It's crazy how quickly today has gone by. Maybe it's because the event's been buzzing with excitement and filled with jam-packed day of hands-on lab sessions, sessions around database, 21C, security, SQL, uh, cloud, and much more, plus some great networking opportunities like attendee match and special interest groups. So we're excited for you to be here and excited to have Oracle's support and participation in this year's event, including the presentation of this keynote session on Oracle Data Management Strategy with Jenny Tsai-Smith. Jenny has been with Oracle since 1993 and has held a number of leadership roles spanning technology support, content development, education delivery, plus Oracle Cloud acceleration of startups and scientific research. And as Vice President of Database Product Management, Jenny works with release and development management to take products and services from design through development to production. And she and her team meet regularly with customers, partners, press, and analysts, and we're excited to have her joining us on stage for the INSYNC keynote. So Jenny, thank you for being here, and I'll now turn it over to you for your session.
Hello, everybody. Thank you so much for joining my session. Data is the invisible power inside nearly every one of our actions and decisions in private, public, and commercial life. Everything we do on our phone and even on this online event create and uses data. Every day, more than $1 trillion in foreign currency exchange happens digitally. All of that money is just data. Everything driven by artificial intelligence, such as recommendations, fraud detection, commercial credit checks, all of it is powered by data. Data, like electricity, is the invisible power inside the modern world. And so creating value from data will increasingly determine an enterprise's competitiveness. And to become data-driven, enterprises will need to build data-driven apps and adopt those paradigms that support the development of these apps. Data-driven apps operate on a diverse set of data, such as spatial, documents, sensor, transactional, and others. And they're pulled from multiple different sources, often in real time, and they create value from that data in very different ways from our traditional applications. Take, for example, a meal delivery app. It may use JSON documents for product catalog data. It could capture order information in relational tables. It could apply machine learning to make real-time recommendations to customers or detect fraudulent transactions. It could use spatial data to keep track of deliveries, stream sensor data from the thermometers in the delivery containers, and apply graph analytics to identify individuals in a community to offer them customized promotions. To keep pace with the business challenges and opportunities, data-driven apps are developed with more agile, scalable, and secure paradigms. Some of these paradigms include microservices to support modularity and scalability, events to trigger process flows, continuous integration and continuous delivery pipelines, plus data access through REST APIs and deeply embedded security measures. So there are a couple of approaches to managing, using, and securing data in data-driven apps. One approach is to use multiple single-purpose database engines, each storing and processing a specific data type or workload type. The other approach is to use a converged database engine which can support many data types and workloads simultaneously. On the left side of the screen are examples of single-purpose database engines, which you can use to build the meal delivery app that I talked about earlier. If you take this approach, you may need 6 different products or services to handle, for example, the relational data, the JSON documents, the spatial data, the social graphs, the machine learning algorithms, and the streaming data from IoT devices. And in contrast, Oracle offers a converged database engine that can handle all of these data types and workloads. So each of the single-purpose product or service requires specialized knowledge, additional costs, plus different operational and security configurations. The fragmentation of data stores not only necessitates data movement, but also forces data transformation and translation across the disparate database engines. This incurs additional integration costs, time, and introduces security plus operational risks due to the many integration points and architectural complexity. So Oracle adopted the converged database approach to reduce complexity, eliminate these risks, mitigate the costs, and whether you create a single database instance, multiple database instances, or a multi-tenant container database with multiple pluggable databases, using the same Oracle Converged Database Engine offers both simplicity and increases productivity. So Oracle's converged database strategy will help our customers future-proof against changing business requirements and ensure the highest productivity for the developers and the data analysts. Let's now take a look at the objectives that we have towards building out this converged database. So basically there are 3 pillars. First one being the database engine itself. We are making it the fastest and most scalable, secure, converged database possible. Running the converged database is the Oracle Exadata platform, which is the most optimized hardware and software for running Oracle databases. And we have added the support of autonomous capabilities to enable customers to very easily run the converged database engine in the cloud. Let me go through each one of these in a little bit more detail. So let's start with the Oracle Database Engine. First of all, I want to remind you all that Oracle Database has had nearly 4 decades of history, and in our DNA is the tenet that this engine should be able to run pretty much anywhere. And so we've taken this approach also to the cloud, meaning the same database engine that you run on premises is also available in the public cloud, in our Cloud at Customer deployment, as well as our dedicated region Cloud at Customer offering. And in the cloud, customers have the ability to choose hosted, co-managed, or fully managed, such as our autonomous services. So the idea is that you should be able to develop your application anywhere and deploy it anywhere so that you ensure that highest portability. In terms of the functionality within the database engine, there was a recent report by Gartner, their Critical Capabilities report, which basically ranked Oracle's engine as #1 in all of their operational use cases and #1 or #2 for all of the analytical use cases. Another testament to Oracle's enterprise scale capabilities is the fact that 97% of the Fortune Global 100 companies use Oracle Database to either run their business or to serve their customers. Let's take a quick look at the database releases and support timelines. So as you can see, we have several older releases that are coming due at the end of their support life. We strongly encourage customers to upgrade to the most current long-term release, which is 19C. It has 5 years of premier support and 3 years of extended support, which ends on April 2027. Also, in the end of 2020, December 2020, we released our latest database version, which is 21C. And 21C has 2 years of premier support. It is flagged as an innovation release, which means that it has a lot of new features. But if you have complex applications where you want to minimize the number of upgrades, you might want to go to 19C and stay there for a while. The main thing, though, is that please take a look at the My Oracle support note for updates on both the database release timeframes as well as the support timelines. Now, let's talk a little bit about the key features in our 2 most recent releases, 19C and 21C. So 19C is, as I said, our latest long-term release. Some interesting features that I wanted to highlight to you include the ability for you to set up an active data guard standby site that could also be a site where you can initiate write operations. So the idea is that not only can you open the active data guard standby for, let's say, offloading analytical workloads or reporting workloads, but you can now also with 19C initiate a DML operation. Perhaps you need to, let's say, update a table to record the fact that a report was generated. You can do that now. And what happens is that DML gets redirected from the standby to the primary site, and the operation takes place on the primary site. So this is not recommended for applications where you have to do a lot of updates from the standby site. This is really meant for a very occasional small DML updates. Another capability in 19C is Cloud SQL. So this allows customers who have data spread out in cloud object storage like AWS S3 to be able to query that data and not have to bring it into the Oracle database if you don't choose to. And so what you do is basically set up, say, external data source as an Oracle database external table. And then with Cloud SQL, you can go ahead and query that data as if it were a table in the database. So this is really helpful for customers who are creating data lakes. Another feature which is really important for IoT streaming data capture is our Mem Optimized Row Store. So the idea here is that you may have devices that need to do a lot of inserts, and we've done tests with 20+ million inserts per second with this feature. And what happens is those inserts get buffered up in memory, and periodically those inserts are basically drained down to disk for persistence. So this is a great feature for customers who want to combine the data streaming support into their application with relational tables and as I said, take advantage of the converged database feature. So in 19C, we also introduced the automatic indexing feature. This feature allows you to essentially let the Oracle Database Engine monitor the workload, monitor the data access characteristics, and then recommend indexes that could help with performance. Also recommend indexes that should not be created or to be dropped, if it's detrimental to performance. And it could even automatically put those indexes to use after it's tested the performance. And so this is a feature that's really helpful for DBAs who don't have the time to monitor the index usage and monitor the SQL plans, but want to be able to ensure that their environment is performing well. And this is a feature that's also used in the autonomous database to ensure that customers can enjoy the best performance without having to incur the time to monitor and manually tune the use of indexes. Okay, so in 21C, we have more innovations that support converged database. And first one is blockchain tables. So blockchain tables allow you to create a table that's essentially immutable. So you can insert into the table, but there are additional functionality that will prevent any kind of updates and deletes on that table. And essentially what it does is it offers protection from illicit changes and further ensures that you prevent any insider or external fraudulent activities on the data in the database. The nice thing is with this feature, it's really easy to use. Essentially, it's a relational table that you would create, but you classify it as a blockchain table, and then there's some additional features to chain each row to the prior row using a cryptographic hash. And then there are additional capabilities added to this feature that will essentially allow you to detect if somebody's tried to change the data, and many other things that you can do to support a variety of use cases. And it will even support use cases that have more interesting governmental compliance type of requirements, such as the European GDPR requirements. Those can actually be supported as well with this blockchain table feature. Another capability in 21C is the support for persistent memory. So persistent memory store is available through the use of Intel's Optane persistent memory chip. And it's basically much cheaper than DRAM, but much faster than flash cache. So by using this, your workloads that are very heavy or very IO bound can basically benefit from this faster memory store, because if you use this on a, let's say a Linux server with Intel Optane persistent memory chip, you can then bypass the IO code path that traditionally will force you to go from DRAM down to disk. Instead, it'll just go directly to the persistent memory store. And so it's just much faster performance. Currently with 21C, we support this on a single instance database. There will be support for rack databases in future release. The other feature that I want to highlight is AutoML. So AutoML in the Oracle Machine Learning for Python in 21C will allow non-experts to take advantage of machine learning, so that customers who may not have the luxury of having data scientists and people with PhDs in artificial intelligence, they could still benefit from the many built-in machine learning algorithms in the Oracle database, and be able to train these algorithms right next to where the data set that's being used to train the machine learning algorithms reside. And the only two things that the person who's using AutoML needs to know is what data set they want to train the data and process the data on, and then what is the value that they want to be able to predict using the machine learning algorithm. And once that's done, then AutoML engine inside the 21C database will evaluate the best fit machine learning algorithm for that data set and for the value that that you're interested in predicting. So, and it'll just spit out a ranked list of algorithms based on the accuracy. So this is something that pretty much anybody who wants to be able to leverage machine learning will be able to take advantage of. And then finally, we also have JSON support. We've had that since 12C, and in 21C, we will store the JSON document in a binary type so that scans are 10 times faster, and then updates to these JSON documents are up to about 4 times faster. And there are many other new features and enhancements. In fact, there are about 200 of them in this release. So this is something that we think that you will be able to explore and make use of. So ultimately, what we're building with Oracle Database, continuing with 21C and forward, is to give you the world's best converged database, providing support for any data, any workload types, and enabling the most productivity for your developers, for your database administrators, and data scientists. Now, you might think that a converged database is shooting for the lowest common denominator in terms of performance and scalability, and that's not the case. So as an example, we did some benchmarking for our JSON documents, and we found that we are actually better than some of the purpose-built JSON document stores, such as MongoDB and AWS DocumentDB. So we are very conscious of the fact that not only do we want to offer support for any data type and any workload, but we want to do it in the most performant and scalable and secure fashion. All right, now let's take a look at the Exadata area and talk a bit about that. So Oracle Exadata is essentially the best platform for all database workloads, both on-premises and in the cloud. It is a combination of the most optimized hardware and most optimized software for the hardware that can be used with an Oracle database. So on the hardware front, we are continuing to add more hardware that is optimized for both compute and storage and networking. And we are very conscious of both the need for the higher capacity, but also at the most cost optimized level. The other thing that's here, which I think is sort of the secret sauce, is the storage software or the smart system software that comes with Exadata. So this software basically provides algorithms that will enable the processing that normally would have to take place in the compute for the database instance to get pushed down to where the data is stored. So it's essentially making the storage hardware smart, and it will know to essentially do the processing where the software, where the data resides, so that it doesn't have to incur the back and forth between the database instance and the storage. So it essentially also allows the consolidation of transaction processing and analytic workloads. And on top of all of this is some special software that will automate the management of Exadata, and it will optimize the configuration, and it automatically detects when faults are about to occur in the hardware, and automatically try to address it, and in some cases, mitigate and prevent the occurrence. So all of this, the three pieces of hardware, special software, and the automation is what makes up the Exadata platform. So we do have a lot of customers using Exadata. Many of them are running huge petabyte scale data warehouses. They are in various industries, including financial services, telecommunications, and so forth. And many of them are also running package applications, sophisticated package applications, such as those from Oracle and other vendors. And oftentimes our customers use Exadata to consolidate thousands of databases onto many fewer Exadata boxes. And some of our customers are also using Exadata to create their own private database cloud. Exadata X8M is the latest version of Exadata, and that was announced about a year ago. It is now available both on premises and in the cloud. The two sort of newer technologies in X8M are the RDMA, Rocky Converged Ethernet. Two of the key new features in X8M are the use of persistent memory. So it's the same Intel Optane persistent memory chip that I mentioned earlier for single instance database, which is more on the database computing side. But this one here is actually PMEM that's located in the Exadata storage cells. And this results in very, very, very low I/O latency. And some of the tests show that it's 50 times faster than flash storage. The other hardware enhancement is the use of the RDMA, remote direct memory access, over converged Ethernet. So this replaces the InfiniBand connections, and this basically allows for faster communication through this standard Ethernet. And we also have more CPUs with more cores and faster clock speed, much more storage. And again, this is available both on premises as well as in the cloud, both Oracle Cloud as well as Cloud at Customer. And in some of the tests that we've run, comparing Exadata against AWS, RDS, and Aurora, you see that both in terms of CPU scaling and storage scaling, we can support much, much more. Many of our customers run Exadata on premises, and they use the cloud as a disaster recovery site. So one example is an electronics manufacturer where they have used Active Data Guard to create a standby on the Oracle Cloud. And on the Oracle Cloud side, it's essentially a hosted disaster recovery site. And in this case here, they're running eBusiness Suite, Oracle eBusiness Suite. Another example is a healthcare provider that is using Epic, which is a package application. And again, they have Exadata on premises using Active Data Guard, but this time they have a sort of a co-managed service in Oracle Cloud, which is the Exadata Cloud Service, and they're using that as their disaster recovery site. And a third example is a government agency. They are using Exadata Cloud at Customer. So this is basically a managed cloud service, but located in the customer data center. and then they have the Exadata cloud service running in Oracle's public cloud as their disaster recovery site. And they're also running a couple of package applications. So as you can see, Oracle Exadata is as a solution suitable also for hybrid cloud requirements. All right, now let's look at the autonomous services. So Oracle Autonomous Database is I would say, our premier offering as far as data management products. But before I jump into it, let's take a quick look at the Oracle Cloud footprint. So Oracle Cloud has been around for, probably on the order of 5 or 6 years. And our second generation cloud was built over the last 2 to 3 years. And our current footprint is even larger than AWS. So we now have 29 regions live around the world, and about 9 or 10 more planned for the rest of this year going into early next year. So that our footprint at this point is larger than AWS's footprint, and by the end of this year, it'll be much larger. We also have a special partnership with Microsoft Azure, so that customers who want to be able to run their applications on Azure Cloud and connect to an Oracle database in Oracle Cloud, they can do that using these OCI, Oracle Cloud Infrastructure, and Azure Fast Interconnects. And as far as we've seen from customers who are using it, they don't notice any kind of network latency or lag at all. So they essentially can enjoy this multi-cloud experience and use the best database and run their applications against the best Oracle database. The other thing I want to highlight here on this map is that we do also have government regions already deployed, and plan to deploy more over the next year, so that customers who are in public agencies and government agencies can also benefit from Oracle Cloud. So the reason why I talk about the Oracle Cloud footprint is that, Oracle Autonomous Database currently is only available in Oracle Cloud Infrastructure. And it is a service that we introduced about 3 years ago. We decided that, our database, while it's the most sophisticated and fully functional, any data type, any workload, it can be somewhat difficult to operate because it has so much capability built into it. And so we decided that we needed to make it really, really easy for our customers to take advantage of all of this capabilities. And so we built Autonomous Database to offer this enterprise class performance, scalability, availability, and security, but make it self-driving. So it's self-operating, self-managing, self-patching, self-tuning, and in some cases, self-recovering, because we know that a lot of that kind of operational aspect of running a database is something that we could eliminate from our customers, IT, day-to-day IT tasks, and allow these IT operational people to spend their time doing things that would be more, even more beneficial for their companies. So, and then ultimately, what we're trying to do is to achieve most productivity. And one of the things that we have done there is also to integrate the Oracle Application Express low-code platform into the Oracle Autonomous Database. So the Oracle Autonomous Database essentially eliminates all the complexities of database deployment and management by running this database on top of the Exadata infrastructure and adding some of the data center operations to cloud operations using machine learning. So we actually gather information about workloads, and we will proactively, eliminate problems before the user even notices that there's a problem. And we will use this workload information to further fine-tune our operations. So, all of this is really what Oracle Autonomous Database brings to the table. Now, the Oracle Autonomous Database is running on the one engine, the one converged database engine, Oracle Database, but it does offer several different personalities that are optimized by use case. So for instance, we have the Autonomous Data Warehouse, which is great for analytical processing, data science, and machine learning. It's, again, the same database engine, but some of the parameters are optimized for that particular type of workload. We also have the autonomous transaction processing flavor of autonomous database, which is optimized for both OLTP workload as well as real-time analytic workload, mixed workloads. And then finally, we have the Json database, which is optimized for JSON document processing. But it is essentially the same profile as the autonomous transaction processing, but with some additional profile parameter settings for JSON. So these are the different ways that you can use the autonomous database. And autonomous database was in the public cloud only, and due to customer demand, we are now making it also available on Cloud at Customer. In fact, this is something that's been available now for about the last, I would say, 10 months or so. So customers who have governmental requirements or compliance requirements where they have to keep the data in their data center, they can make use of autonomous database with this version, with this deployment in Cloud at Customer. And so the control plane, the cloud control plane, has a connection to the customer data center, and this is how we can monitor and manage the autonomous database that's running in their data center. We also have a free service called DataSafe that will offer essentially a single unified security service for all of your Oracle Cloud database services. So this is actually available for Database Cloud Service as well as for Exadata Cloud Service. And we added support recently for on-premises databases as well, so that if you have your database running in your data center or perhaps in another cloud, this DataSafe service will be able to assess the data security compliance. It will be able to audit all the data and even do things like discover sensitive data. We offer probably over 100 different data masks that will allow you to essentially use these data. Actually, they're more like data patterns, data format patterns, so that you can say, okay, scan my database and look for tables that contain data that appear to be like social security numbers. And it will go ahead and find that for you and then flag them as tables that perhaps need a bit more security applied. And you may even want to mask or redact the data depending on the requirements. So this is a data safe service. It's running in Oracle Cloud, but it can manage and monitor your database on premises. And I mentioned earlier that Oracle has a low-code application development platform, the Oracle Application Express platform. It's now available as a cloud service, so it's a fully managed stack. It's really a stack of the Oracle REST data service plus Apex, and sitting on top of the Oracle Autonomous Database. And it's all there for a low price of $360 per month. There are no extra fees per user, per developer, or even per application. So it's a single monthly fee, and you get 1 terabyte of storage and 1 OCPU, which is equivalent to 2 virtual CPUs. And that's really enough to run pretty much most applications that we've seen customers build. It is used by developers, whether they're line of business or citizen, or even the professional developers who want to be able to create an application quickly and then take that application and further augment it with JavaScript or other kinds of code that they want to add on to the Apex application. The thing that we think about when we talk about Apex is that coding should really be the exception, not the rule. So even if you're a very long time application developer and you like to write code from scratch, we don't think you need to do that. We think that the best way to write code is to start with code that's generated by Apex, and then you can add on to it as you need. In fact, we did a time and motion study comparing Apex against the React JS, React JavaScript. And what we found is that it's 38 times faster to develop an application in Apex than in React JS. And you don't have to write as many lines of code. So 20 times less lines of code in Apex versus React JS. So, it's definitely a productivity gain there. And looking into the future, what are we doing with Autonomous Database? In fact, this is not so much the future because we just announced the addition of new built-in tools inside the Oracle Autonomous Database that are particularly useful for people who are working with data warehouses in the cloud. So capabilities that will allow anybody to be able to very easily, using some declarative tools, to load the data, transform the data, better understand the data model automatically, be able to discover data insights, correlate data across the data sets, be able to build social graphs and to apply spatial analysis, to be able to run machine learning algorithms to train and infer and predict data values. And of course, use Apex, the low-code application development platform, to be able to become more productive with your data. So all of this is now actually in the Oracle Autonomous Database. These built-in tools are called database actions, and it's there out of the box for you when you create your Autonomous Database instance. You see that we also can support data sources from other places, such as package applications, from Oracle and from some of the other vendors. We can support data from files that are stored in object storage, streaming services, whether it's Kafka events, Kafka streaming data, or Oracle Cloud Streams data, and bring that all into the data warehousing solution that you're building. And of course, we support many different BI tools, not only from Oracle. Of course, Oracle Analytics Cloud is probably the best out there, but also from Tableau and Microsoft Power BI tool and other vendors that have BI tools that you want to be able to connect to the Oracle database. So let's take a look at one of the Oracle customers who is taking full advantage of the capabilities within our converged database. Mindsense is a pioneer in the digital mining solutions area. They put very heavy-duty X-ray devices on the buckets of excavators to scan chunks of rock as they're being dug up. These scans let the mine operators know how much ore is in each chunk, which then lets them sort the chunks much better for processing. The result is more recovered ore and a lot less wet waste. So the key to all this is the data. Mindsense feeds data from the X-ray scans as well as other sensors on the excavators and mining trucks into several autonomous databases in Oracle Cloud. They use Oracle Application Express, which is we talked about as the low-code app development environment, which is part of the Oracle Autonomous Database. And they use Apex to build multiple apps for different uses of that data that's being collected. The data is used for analytical dashboards for the geologists, for the data scientists who build the algorithms, the machine learning algorithms running in the X-ray devices. They also, in fact, run a smaller version of Oracle Database and Apex applications on the excavators themselves to help the field technicians with diagnosing problems and with repairing the equipment. So this is why Mindsense chose Oracle, to have a unified distributed data tier that gets data from its point of origin on the machines in the mines to the many different places and applications used for analytics, for artificial intelligence, and so forth. And all of this is done with minimal time, cost, effort, and risk. So I've walked you through what we've been doing with Oracle Database. 19C and 21C are here, and 19C being the long-term release, 21C being the most recent innovation release, and they're available on premises as well as in Oracle Cloud, serving you the converged database technology that we think will make you the most productive. We have Oracle Exadata X8M and the new capabilities that are offered through the Rocky and persistent memory hardware. And then finally, with Oracle Autonomous Database, you get the automation that is enabled by the built-in machine learning, and you can run this in the public cloud or cloud at customer in your data centers. So thank you very much for joining me today. And I encourage you to go check out our latest Oracle Database 21C in the cloud for free through our always free autonomous database. Thank you very, very much. And feel free to connect with me either on LinkedIn or on Twitter.